Video is about limits. And so we have this graph right here, f of x. And so you can see there's a lot of crazy things going on with it. And so before we talk about limits, we're just going to talk about something that you know how to do, which is how to find the value, the y value of a given x value for a function. So for instance, right here we have f of negative 3. That is, this is asking, f of negative 3 is the y value that you get when you plug in x is negative 3. This is what it's defined to be. This is what you have known before. This is not a limit. This is very different. So let's go ahead and answer these questions. F of negative 3, f of negative 1, f of 2, and f of 3. These are what point is defined there. So when x is negative 3, this is negative 1, negative 2, negative 3. There's a solid point here, and so the function is defined to have a y value of 0. This is equal to 0 right here. Right here, f of negative 1. When you go to negative 1 right here, there's an open circle, but then there's a solid circle above at the y value 3, so f of negative 1 is equal to 3. F of 2. When I look at the x value 2, I go up, there's an open circle, and it's not defined anywhere. So this is undefined, is what that is. And f of 3, when I look at f of 3, there's an open circle, but up here is where it's defined. It's defined to be 4. So that discussion is about what these points are defined to be. So in other words, when x is 3, y is 4. When x is negative 1, y is 3, and so on. So this is what you have known for most of the course, but now we're going to discuss what a limit is. A limit is what it looks like the y value is approaching as you get close to an x value. So for instance, I have written the limit as x approaches 1, and this 1 has a negative up there on the right side. So this reads, the limit as x approaches 1 from the left. That's what that reads. So let's see. Let's look at this graph. Here is the x value 1, and from the left, we're coming in from this side over here. So and you just sort of ride the curve in. So as we get close to the value x, so if you look at this right here, let me grab a pen right here. As you're getting close to the value x right here, from the left, we're writing the curve in this. It looks like it's approaching this point, and the y value right there is 0. So the limit as x approaches 1 from the left is 0. Then let's say, what happens when we approach the x value 1 from the right? So we're over here on the right side, and as we approach 1 from the right side, we get close to this, and it looks like the value is also 0. Now, if you approach an x value, and so let's talk about 1, we're approaching 1, and you approach it from the left side over here, and you approach it from the right side over here, and the limit from the left and the right agree, and they do in this case, then you can talk about what the limit as x goes to 1. Do you see how this 1 does not have a little plus or minus up there? This means the limit as x approaches 1 from both sides. If they both agree and they're the same value, then you can say, you can answer that question. Let's look at this one, for instance. The limit as x approaches 3 from the left. So here is 3. And if you're coming in, if you're approaching the x value 3 from the left, we're on this side of 3. So if we're writing, so you sort of just ride the curve in. We're getting close to 3 from the left side, so we're on this side, we're writing it in, and when we get to x equals 3, it's approaching this y value of 4 right there. So the limit as x approaches 3 from the left is 4. Well, what is the limit as x approaches 3 from the right? So if we're writing the curve in 3 from the right, we're on this side of the curve, and we're getting close to 3, it looks like it's landing at this y value, which is a 1. All right, then that means that the limit as x approaches 3, and it doesn't have a plus or a minus, so what that means is we consider what is the limit as x approaches 3 from the left. Okay, it's 4. From the right, it's 1. These do not agree, and so we would say that the limit as x approaches 3 does not exist. If it doesn't agree from each single-sided limit, then it doesn't agree in general. All right, so let's look at this example. The limit as x approaches 2 of f of x. They did not give us a little plus or minus. Those are called one-sided limits when they have the little plus or minus. When they say the limit as x approaches 2. So let's look at 2. Here's where 2 is. Okay. As we, on our own, without being told, we approach it from the left and the right. So if we approach 2 from the left, we ride the curve in, and it looks like it's headed to this point, which has got a y value of 2. And if we approach it from the right, over here on the right, we're riding the curve in from the right, and it's approaching the same value, 2. The limit as x approaches 2 of f of x is 2. Now this is interesting because look at what is f of 2 defined to be. It's undefined. So now we see that a limit can exist even if the point is undefined. A limit is different from the definition of a point. F of 2 does not even exist. It's undefined. However, the limit exists because it looks like as we get close to 2 from both sides, we're headed to the y value of 2. What is the limit as x approaches -1 of f of x? Okay, on our own, we say, what is the limit as it goes to -1? From the left side, we ride it in the curve, it's going to hit 2. What is it from the right side? We'll ride in the curve, it's also going to hit 2. The limit as x approaches -1 is also 2. However, f of -1 is defined to be the value 3. So we see again that the limit as x approaches a value is not at all the same thing as what it's defined to be. It can be what it's defined to be, but it does not have to be. And it doesn't even have to be defined. Okay, last example. What is the limit as x approaches -3? Okay, from the left. If we're coming into -3 from the left, it's going down. That's the arrow. It's going down to -infinity. As we approach -3 from the right, this is the arrow down here, it's going to -infinity. So that is limits when we have a graph.